Okay, so first question we're going to look at is this one here. So somebody sent me in a question saying they weren't sure about the kind of questions where we're asked to find an angle that's outside of the shape we're trying to work out. So what we've got here is we've got our triangle with this line continued on here, and we've got two angles within the triangle, but the angle we want is outside the triangle. Okay, so what we're going to do, and this is my top tip really, is if you are unsure about how to get to the angle you're trying to find, just work out any angle you can. So I would look at this problem and I would say, well, one thing I can work out is I can work out this angle here. Okay, so that's the first thing I'm going to do. I'm going to work out that angle there. Now I can work out that angle using the fact that angles in a triangle sum to 180 degrees. So what I'm going to do is I'm going to add together the two angles I've got. So I've got 57, I'm going to add on 43, and when I add those two things together, I get 100. So the two angles we've got within the triangle add up to 100 degrees. What I'm now going to do is take that away from 180 to work out this angle here. So 180 minus 100 equals 80 degrees. Okay. And then what I would always do is then label that on the diagram. So I now know that this angle here is 80 degrees. It's not the angle I want, but that's not a problem. Okay, we can still use that. Now what I would do then is I would just concentrate on what's the relationship between the angle I've just worked out, the angle I want. Well, I can cover up the rest of it really, and now just look at it as an angles on a straight line problem. And we know that the angles on a straight line add up to 180 degrees. So the angle I want, x, will be 180, take away 80, which is 100 degrees. So my angle that I want, x, is 100 degrees. Okay. Now in an exam, you may also be asked to write down the angle rules you've used. So the angle rule we've used here is angles on a straight line. No, they're not. It's angles in a triangle sum to 180 degrees. And then here, when we were just working around here on the diagram, it's angles on a straight line sum to 180 degrees. So I've got my working out shown clearly, I've got the angle rules I've used, I've got what x is, it's 100 degrees. Okay, on to our next question then. So our next question is one involving parallel lines. We know we've got parallel lines because they've got these little arrows on them, so this line and this line here are parallel. And what we're being asked to find are two angles, angle A and angle B. Okay, now this one is a little bit complicated. It can look a little bit overwhelming because we've got two angles to find. There's a lot going on here. So what I would always recommend you do is just focus on working out one of those angles. Now this angle here, the first one we'll work out, A, is linked to this angle here of 134. They're on this same line here, this transversal that's going through the parallel line. So what I'm going to do is I'm going to ignore the rest of the diagram. I'm just going to focus on this. Okay, so if I do this, again, we can just work out any angle we can. So the first angle I'm going to work out is this one here. So if we do 180 degrees, take away 134, because I know that these two angles lie on a straight line, they will add up to 180. And 180 take away 134 is 46 degrees. So I now know that this angle here is 46 degrees. I can now start thinking about my angle rules with parallel lines. Now if I have a look here, what I can see is I can draw an F here with the two angles in the armpits of the F. So they are corresponding angles, which means that these two angles are the same because corresponding angles are equal. So now we can just write down that A is 46 degrees. Our angle rule is corresponding angles are equal. Okay. Now we can take a similar approach with our second angle we need to find, B. Okay. So again, there's a few different ways we could go about working this one out. What I'm going to do is I'm going to use angles on a straight line again. So this time I'm going to use angles on a straight line to work out this angle here. So I know that these two angles must add up to 180. So I'm going to do 180, take away 69, and that will give me 111 degrees. So I know that this one's 111. I'm going to label it on my diagram as 111. If I've worked out an angle, I'm going to label it on my diagram. And then again, we've got that kind of F shape. This time it's an upside down F, but we've still got two angles in the armpits of the F. So those two angles are corresponding, which means that those two angles are equal. So that means that angle B is 111 degrees. Again, we've used corresponding angles, F angles are equal. Okay. The other angle rule we have used in both of these, which I haven't written down, and I suppose I should have, but I'm a rebel, is that we've used angles on a straight line add up to 180 degrees. So we could also add that to our solution if we wanted. Okay. Let's move on to one more example before I bore you too much, which is this last one here. So again, we've got a lot of things going on here. This time we've got a triangle. Okay, we've got an isosceles triangle. We know it's isosceles. We've got these markings on two of the sides, which means that these two side lengths are the same. So it's an isosceles triangle. And we've got a pair of parallel lines. We know they're parallel because they've got the little arrows on them. We've got this angle here is 115. We want this angle here, X. So let's give it a go. So the same as last time, what I would recommend you do is just work out what you can. So the first angle I would work out would be this angle here. Okay. So I can use angles on a straight line here because I've got these two next to each other. Again, if we wanted to, we could ignore everything else that's going on and just say, well, we've got angles on a straight line, so I can work this one out. So this angle here, I'm going to calculate by doing 180, take away 115, which is going to give us 65 degrees. So same as usual, once you work out an angle, label it on your diagram. Okay. So I know that that angle there is 65 degrees. Okay, I've used angles on a straight line. Sum to 180. So next thing we do is let's have a look at what's going on. Okay, what we've got here is we've got an isosceles triangle. Now in an isosceles triangle, two of the angles are the same, and it's the two angles that are at the bottom of the side lengths of equal length. So this one is also 65 degrees. Okay, we've just used the properties of an isosceles triangle there. And then what we can do now is we've got two of our angles in a triangle. So we know that the angles in a triangle add up to 180. So I'm going to do 65, add 65. They're the two angles I know. When I add those together, I get 130. And then I'm going to take that away from 180 to give me the one angle I've got left. So I now know that this angle here is 50 degrees. And we could do a quick check, add these three things together, see if we get 180. Do they add up to 180? Yes, they do. We're right, yeehaw. Okay, so now the final step is how on earth are we going to get to Z? Again, what we can do is we can ignore a lot of what's going on in the question now. We can just look at what's going on over here, and we're able to draw ourselves that Z shape. And we've got two angles there that are in the corners of the Z. So they are alternate angles, and we know that alternate angles are equal. So that means that if this angle is 50, then so is this one. Okay, so that means that angle X is 50 degrees, and our reason is Z angles. We can't write down Z angles. Z is a nice way of us spotting when two angles are alternate, but we need to write down alternate angles are equal. Okay. So hopefully those three examples have been useful. If you have any other questions, then obviously you can still send me a comment through the VLE, and I will get back to you as soon as you can.